Welcome everybody to the final session in the Kicks track this afternoon. This is session, just checking, really should be better prepared than this.
4F.
4F, thank you, Andrew. This is section 4, tutored by Andrew Smithson from IBM. Just a couple of notes before I hand over to Andrew. This session is being recorded, so be aware of that. You're all on mute for the duration of Andrew's presentation, but we will unmute everybody at the end for questions. If you do have questions during the session, please use the chat facility in Zoom, and both Andrew and I can see the chat, so one of us will spot a question if you put it there. I think that's all I need to say at the moment, so I'll hand over to you, Andrew, if you want to take it away.
Thank you very much, Steve. Good afternoon, everybody. As mentioned, my name is Andrew Smithson. I am the architect for ZOS Connect, based out of IBM Hursley. I've been with IBM 20 plus-ish years now, and I've been working on ZOS Connect since it really came into being as a product. So really excited to talk to you today about a slightly different way of looking at API integration with your mainframe. So normally when I get up and stand in front of a lot of people, it's about exposing data out of the mainframe using your existing Kix programs and IMS transactions and things like that. Whereas this session, we're looking at taking it the other way. There's a whole bunch of APIs out there that have information that you may need to use and consume as part of your mainframe applications, and how you can do that in a way that is consumable to your mainframe developers, using COBOL structures and aspects like that they're very familiar with. So just as a bit of a level set, we'll talk about, again, what a REST API is and what it is about them that has really grabbed hold of the developer communities and really made them kind of an underpinning of everything we're doing in cloud and hybrid cloud environments today. So REST is an architectural style that we talk about it for accessing and updating data. And it comes down to there's generally 4 things that we want to do with any particular piece of data. We want to retrieve it, we want to update it, we want to delete it, or we want to create a new one. And those 4 operations often map really nicely onto the HTTP protocol and the verbs that are used there. But you don't have to use HTTP to have a REST interface. And also, not every API that you access over HTTP will be RESTful. Web services uses HTTP, and they are very far from RESTful in that type of thing. But the main thing from following this kind of architectural style and way of doing things is that, if you can follow these best practices, can follow these ways of working with things, then they become simple and intuitive for the consumer of that API, the developer, to actually get hold of this information and make use of it inside their applications, inside the front end things they might be doing as part of some other back end processing that's going on. And typically the way that we do this through ZOS Connect is we work with HTTP-based REST APIs and have those interfaces defined using JSON, which is a JavaScript object notation, which gives us a semi-human readable way of viewing the data and working with that. So what is it about REST that has kind of allowed it to gain that popularity? So it's that ubiquitous foundation that we talk about. We say it's not always HTTP, but it is based on HTTP. There are 4 main verbs that get used in HTTP of get, put, post, and delete, and they map really nicely one-to-one onto those 4 operations that we talked about previously that you'd want to do on your data. Compared to, as I mentioned earlier, web services where you had SOAP and WSDL and everything like that, it's a lighter weight way of describing things. JSON is a lot lighter in terms of its syntax that you have to have around the data, and also it's a lot more self-describing. So it's actually, you can get more data into fewer bytes. It's not obviously going to be the most optimal. If you go down to binary, you get things a lot tighter. But it finds that happy medium between getting the data across efficiently, but also being something that's easily consumable by those consumers of that API. They can look at the JSON they get back. They can look at the schema that describes it and easily understand what they have and what they can do with the information they've provided. The other key thing is that because it's based on a lot of these standard type things, nearly all the programming languages that are used and worked with today have some base level way and then libraries that sit on top of working with those REST APIs. Every language has a way of accessing a socket, can access data over that, and predominantly now with JSON being that format, there are JSON libraries and ways of working with that JSON data. So it doesn't matter what programming language you want to be using, what system you're going to be running on, being able to access that data is exactly the same from whatever system, from whatever language. So you're not kind of baking in those, oh, I'm running on Windows, so I've got to use this particular version, or I'm running in this application server, so I've got to use this set of libraries. You get that freedom and that choice to use what you need that suits your deployment and the space that you're working with it. And then the final one that we talk about here is stateless. And this makes things a lot simpler as you go through without having to track state through a number of requests and things like that. Again, you get that that ease of use, that greater simplicity in how you do things and how you model things, because each request is its own effective transaction. We're not having to do multiple requests to do a singular update. You do an update all at once, and it either all succeeds or it all gets rolled back. So it's a really useful and predominantly the way that most things are being done these days. So as Steve's just posted, I am keeping an eye on the chat as developed by spotting that one there. So please, at any point, feel free to post a question in there. I'm very used to having interactive sessions when we do these conferences in person with questions and requests for things being made clearer as you're going through. So please feel free to do that as you're going through, or save them to the end, and we'll try and get through as many as we can. So within ZOS Connect, we have the concept of, we talk about an API requester. And that's an application where, in this point, instead of providing an API, we actually want to request data from an API that could be running on a mainframe out somewhere in a cloud, somewhere else inside your business. And these are how we manage this, and we provide a set of interfaces that are easily consumable by the mainframe application developer, and also provide some qualities of service around other aspects of the REST API and how you use it as we go through and talk about this. So this is kind of the generic architecture box diagram that we talk about. So, and it completely turns it around from what we normally have. So this time on the left, we have the ZOS subsystem, our mainframe, our Kix program, our IMS transaction, our batch application. And then we have our API requester deployed into ZOS Connect. And we have a host API that we provide as part of your ZOS Connect install that allows your ZOS application to send data to ZOS Connect in a style that is familiar to the developer inside that ZOS application. ZOS Connect can then communicate with the API endpoint wherever that happens to be, do all the necessary RESTful things like making sure the path parameters are set up correctly, any query parameters are in the right place, create a JSON body to send in the request, get the JSON body back from the response or the status code that says something went wrong, it wasn't found, there was an error or something like that, and then transform that back into something that can be easily consumed by that same ZOS application. So the ideal thing is that at no point does your ZOS application have to worry about how they construct the URL to talk to with the API endpoint, how they get the JSON formatted in the right space with the right curly braces and square braces in the right places and matched up. Everything like that is taken care of for you by ZOS Connect, and you're left to just deal with the data that you care about, that you're getting and putting it into this API. And in a sense, it's very similar to a lot of the libraries that you can see in other applications that will take an API specification and give you a set of Java APIs or things like that that work with that and do that under the covers as well. So ZOS Connect is really good for this, and there's other qualities of service again that we'll build up as we go through. So OpenAPI 3 is the latest version of the OpenAPI specification. It's been out for a number of years, and since 3.065 of ZOS Connect, we've been able to support that in OpenAPI in API requesters. Initially, support was just there for Kix programs. More recently, we've added support for batch applications, and the development team are actively working on getting IMS support available as well in this OAS 3 environment. We make use of Gradle to do the generation of all the artifacts you need, and you're going to need the OpenAPI 3 specification that defines the API that you're going to talk to. And this specification is absolutely the key crucial thing for all these things. Anybody that is providing an API will give you one of these as that document and that and contract of how you're able to call the API and what information you're going to get back. So at this point, I'm going to drop out of the slideware and go back to something I'm a bit more comfortable with, which is a development environment. And we'll go through kind of the steps and what you have working in terms of generating all the artifacts for an API requester application, building that into a Kix program that has a number of transactions alongside it, and then what that looks like, and we'll talk about some other things around that as well. Just bear with me 1 second. Sorry about that. Dangers of working at home when the children are around. We also have then our, here we have the OpenAPI specification that we've asked about. So we can see here, this is one that we provide as part of our sample applications. And it is a API for accessing information about Redbooks that we have available. So we can see it's got various operations that we can look at. We can do a get on a book via its title. We can do a get and get all the Redbooks that we want to, that are available within that system. And so we can take this, and then we can also add in some configuration around it that talks about how we want to generate the copybooks that we're going to work with. So we need to say what language we're working with. At the moment, COBOL is supported. PL1 is also, I'll have to go back and check. If it's not available, it will be soon. And there's other defaults and information that we can set up. The other thing that we can put in is the connection reference that talks about what connection inside our ZOS Connect server is then able to pick up and use the, has the details of that remote API that we're going to talk to. So with those two key documents available inside our structure, we can do a Gradle build. And what this will do is it will, if we don't already have it, pull all the plugins and stuff we need for building and working with these structures. It will parse that OpenAPI document, and it will generate a bunch of copybooks for each of the operations that are defined in there. So we can see in the console here that we had 3 operations that were found, and they were all parsed successfully. And when we go up to our build directory, we can see then that we've generated some copybooks. We look at the get Redbook. copybook. We have some general information around it. So information about what path it's going to be needed and the method and things like that are encoded in there. But then we can also see the requests and the response fields that we have available to us. So there is a path parameter on this thing that is optional. So we have that converted into a picx string that we can use. And we also have, oh, sorry, it should be the get all books I'm looking at. So we have a single query parameter on this one that's optional. So we have a bit that says whether it exists or not, and then we can optionally pass in that string as we're going through. We also have the response copybook that comes back. This is a bit more involved because there are multiple responses that can come back from a particular API. So one of the other key things about using HTTP as a method for communicating with your APIs is that the HTTP status code provides a lot of information just by what it is. And a good REST API will make use of those standard conventions and namings of a HTTP status code to use what's needed there. So rather than if you put a request in and the item you requested wasn't found, getting a response body that has a field in that says not found, the API should just return a 404 because 404 is the HTTP status code for not found. Hence why we see it on all those web pages when we can't find the page we're looking for. 500 is a server error. 403 is for security and things like that. So by using those status codes, the API can confirm meaning to the consumer of that API without them having to go through the process of actually parsing all the response for potential optional fields and things that might be set or not, depending on what was going on. What we had in the first versions of API Requester that used the Swagger 2 specification was that we would do all the parsing and the transformation of the JSON object for the 200 response for you, and you get a copybook. For anything else, we just gave you the JSON. So we only did part of the job. With the OpenAPI 3 support, now everything is translated into a copybook for you. And you can see that here we have both 200 and 404 defined as copybooks. So the 200 has all the details about the book that we're going to get back. And the 400 also then has things about the message or what it is that came back and that field that is defined there. So with all these copybooks produced and generated, we can then go and write our Kix application. So again, this is our sample one. I've regenerated some stuff, so my editor's not quite happy with that. But we can see that we copy in the copybooks that we need to, including some ones for some standard ones that are provided with the ZOS Connect install. And then we can go through and we can start actually processing it. Now, probably the easiest way to do this is to actually process it. So I've got my Kix region that I've got set up. And there's a whole bunch of programs and things like that that get installed as part of the host API process. And there's also a key one is a URI map that we define. And there's a default one that we have, and this says to the host API, where is the ZOS Connect server that we want to communicate with that knows how to process this API requester. So in this situation, it's running on the same system that my Kix region is. So we can just point it at localhost and the port that we're listening on. With the ZOS Connect server, we've set that up as we have normally. Alongside all the copybooks, we also get produced a singular WAR file. Now, this is the OAS3 equivalent of the ARA files that we used to produce. And that gets deployed and managed as like any other Liberty application inside the ZOS Connect server. So you can put that into the relevant directory on your ZFS under the service directory, add your configuration to server XML. which we can show as well. So again, we can see here that we have our HTTP port. That's the wrong server, XML. So we can see again, we have our HTTP port of 9080. We can also see that we have our endpoint connection of Redbook connection that we had defined, and the URLs and the information that we have around that. So we'll go back to the Kix region and we'll run the transaction that gets all the Redbooks from the system. So we'll start that running, and instantly it appears to hang because I've set up the debugger to go through and show us what's going on inside the system. So we can actually show a bit live what's going on. So, and the zoom thing is going right over the debug menu. That was the one thing I didn't spot. Okay. I was going to say, well, okay. So we've jumped into the program. So we've jumped straight in. And the first thing that we need to do is we need to connect to the is to initialize our connection to the ZOS Connect server. So the first thing we then do is we call the BAQ init function. And we have a bunch of these areas that are set up to reference the information that we're going to. And as we then kind of step over that, we can check whether we got a return code. All these things are in these response areas. So we can show the return codes. They're all 0. So that's good. So we've successfully established our connection to the ZOS Connect server. Then what we need to do is initialize the request structure that we're going to do. And in this situation where we're just getting all the Redbooks, there's actually nothing to do there. So we can jump to the next point, which is then to actually invoke the API operation that we want to do. So we set up our BAQZ connect area. Which will point at the information area that we had before. So there we go, BAQ requests area. We can see that we don't have any initialization parameters or any parameters that we need to pass through in this situation, but they'd all be filled in there. And what this then does is it takes that copybook and the information we need to do, sends it to ZOS Connect, which will then go off, create the JSON and the URL structures and everything we need to then go off and call the API. Well, this one does take a little bit of time because we're actually going off and calling that remote API. But that's come back. So we then can set the response message and we can check the response area and we can see that we got a status code of 200. So we know that that call to that API succeeded. If we'd had a 404 or some other error that had been defined, we get that status code in there as well. So we can check within our application what we got back from the remote API call. ZOS Connect will never make a decision that because it wasn't a 200 from that return code, that it wasn't successful. That's between you and that remote API based on that open API contract. So we can step over that. Now, one of the other things that we have within this open API and is that the authors and the books that we get back is just defined as an array with no fixed length, because often in languages that are used out on these cloud APIs, we've got Java, we've got Node, they don't care about variable length arrays and things like that. They will just allow you to go through and do stuff. But when you're working in these things, we're working in COBOL and, having to have a fixed length. Well, either we've got to allocate an amount of memory that is big enough for how big it possibly could be, if we even know that, and very often it won't ever be that big. So you end up with lots of wasted storage inside your applications because you're hoping for a request that could return 100 items when all you got back really was 2, and things like that. So within the OpenAPI 3 version of API Requester, we've learned a lot from our friends in Kix, really, and have used a concept similar to the channels and containers approach, where ZOS Connect will manage the memory required for that data structure, because we can be a bit more dynamic when we're working with the ZOS Connect system and the host API on how much memory we need to allocate for that response. And then we can give you access to each of the items in an array in a iterative fashion. So you can just ask for the next version or the next element in that array until you get one. So you only ever need to have in working storage one copy of the items that are in that array, hopefully massively reducing the amount of storage that's required and things like that. So we do this by using a getN name, which just gets us the next item in that array. And as we go through that, we can then get the next item. We can map it onto our response code structure. So we then scroll down into the system here, and it's a RBK02. Where did you go? It's always the way, as soon as you try and look at these things, they all disappear. So there we go. So found it now. So we can then see that we've mapped into this structure that just contains one item, the title that we got back, along with the the status for it, the number that we have for it. The authors, again, is a array, because a book can have 1 to n authors. So again, we can see that we've got a data area reference for the authors, and we could then go through and iterate over those as well if we wanted to get through this. And in this particular example, all we do is just print out the title. So we can just go through this a few times. Right. Oh, cancel. Right. So that's completed that program. We can switch back to there. Eventually this will wake up and it will show me a list of all my titles. But that was going through that program, and that was going out and calling a real REST API. You're going to wake up. There we go. Just hit enter. And then we can see. So we've gone off, we've called the API. We've got a list of all the books that we had inside our database, and we can output that with all the titles that we had there. And we could work with any of the data that we had there, and we could display it like that, or we could combine it with something else we have in our system to work in that area. And at no point in that COBOL program that we had there did I have to work with the JSON. Did I have to try and drill down through layers of nesting and things like that might have been set up? It was all just there referencing things inside a copybook that as a COBOL programmer, I would be very used to doing. So I'm just going to switch back to my presentation. So the API that we call to host that API is running out in the cloud. It's been implemented out on the AWS cloud using a whole bunch of their serverless functionality and a document database to store the information. And again, this is all hidden from the COBOL developer who just has that open API specification that they use to generate the API requester. And then they bring it all back in. So hopefully we'll make these slides available after the session. So these just go through all the steps that I've just talked about and what you're working with and how we deployed the API requester application and make sure all the configuration and things like that were there. So I'll just take a pause quickly. So the final thing that we need to talk about whenever we're dealing with APIs and data and that is security. And it's very often in the case that in these demos, you run without a security context on there. It makes it safer. It makes it easier not to run into challenges where the security context might fail or your password's expired or things like that. But I'm running this API out on the public cloud where anybody with the URL can access it. And I don't trust that somebody's not going to find it and completely trash my database or put something very inappropriate in there. So this API is running with security. And in order to call any of those operations on that API, you have to get hold of a JWT from the authorization server and pass that along with every request that you make into the API. Now, the key thing that you didn't see in the COBOL program I showed you was me going off and getting the JWT and attaching it to every request I did. And that's because ZOS Connect takes care of that security for you. So the details of the security server and how you get hold of that JWT are defined within the server XML configuration of the ZOS Connect server. And it does it like this. So we can point out not only where the API is, but also where the authorization server is and what type of authorization we need. And authorization servers come in all flavors and varieties, and they all have their different requirements about what you need to pass in and where you put those things in. In this one, we just need to pass in some client credentials to the auth server, and their identities have been protected for the purposes of this recording. So every time we need to get hold of a JWT for this request, ZOS Connect will make a call to the authorization server using the credential information that either we have stored within server XML, or it can be passed from the mainframe application itself. So you can have that kind of identity propagation tree going as we move through with things like that, through ZOS Connect out into the other APIs. So one of the other questions you might be asking is, well, okay, so if it's just making an HTTP request and we could have an open API specification for that, why don't we just spin that up as another API requester and then we could do that ourselves? Well, you could, yes, absolutely. But the key thing with JWTs is that they have a time to live. So once you've requested a JWT, you can keep using it within a certain defined time period that's defined inside that JWT until it expires. So you don't have to keep going to authorization server, which improves your performance in a heavily loaded system. You don't want to be making 2 calls every time just to do one API operation. And so if you were doing this yourself, you've then got to do caching for your JWTs based on the credentials that you're using with them. Or you could just let ZOS Connect do that for you, and we'll manage that security context for you. And we'll manage those JWTs, and we'll know when it expires and request a new one because it's expired. And we'll know that beforehand, rather than having a request go in and fail because it's expired, and then you've got a security failure on the other system that starts, the classic thing of you've entered your password wrong too many times and your ID's been revoked. Which you don't really want to be doing in a production environment as well. So there's some really good stuff there. And this is really where a lot of the power and the value comes from using something like ZOS Connect to manage your outbound API calls and provide that flexibility. So not only do you have the more manageable way of working with the data and doing that in a managed way, you've got ZOS Connect managing the connections between both the host system and the ZOS Connect server, and the ZOS Connect server to the remote API. And then all the security considerations around that as well are handled and managed in that situation, allowing your application developers really to focus on what they need to work on, which is using the data from that API. So whether that's a fraud checking service or a credit scoring service that you need to quickly call with a bunch of information for a process that's going on, get a response back and act upon that response as quickly as possible and as reliably and securely as possible, this is the way that we recommend to do this than IBM. But certainly having REST APIs as part of your overall engagement and hybrid cloud, both to and from the mainframe, is something that we would really suggest you consider and things like that going forward. So as pretty much as predicted, I've taken about half an hour to 40 minutes. This has been session 4F. Please provide your feedback. It's very much appreciated by all the speakers. We find it really useful to know what's been useful within these conferences and what we need to look to provide more of at future ones. And hopefully at this point, Steve's going to open the floodgates for any questions. We've got time here. They can be on this or they can be anything else around APIs on Z. I'm happy to try and just take any questions at this point.
Thank you, Andrew, and thank you for finishing early, giving you the last session. So everybody should be able to unmute themselves now. If you do have a question you've been saving up, we'll just pause for 10 seconds or so, so you can bring yourself off mute and ask your question.
Just one question. I was interested in the way you were handling arrays.
Yes.
Which I think is a problem. Is there something similar on the other side, the sort of for inbound APIs? Because, or rather, because we often have the thing that we have a COBOL program that gets an array of data, and the size of the data structure, could be a huge number of rows in an array to send out to the JSON to whoever's calling kicks. And again, it's, is there a certain thing like that where you could build up the JSON array iteratively rather than having a huge COBOL structure?
Right. So if I can just play back the question. So in our API provider scenarios, your COBOL structure that you've imported into your ZOS asset is defined as occurs 100. And you generally got 2 items in there. So yeah, we end up with an array of 100 items. And so yes, there is a solution. It's certainly within the OpenAPI 3 and the ZOS Connect Designer. What we provided there is we've embedded a functional language called JSONata that allows you to do functional type programming aspects across the data. So there's 2 ways to easily manage it. One is often there's another field in the copybook that says how many pieces of data are actually in this massive occurs. And if you've got that, you can use that to directly trim the array and say, actually, don't send me everything, just trim it. The other thing you can do is you can programmatically trim it. So you can iterate over it inside ZOS Connect and remove any elements that have empty fields and things like that in that. If we don't have examples in our documentation for that, I will take an action to look and getting some examples of that into the documentation, because that is another key thing around, fixed data structures versus variable data structures that we definitely want to support you going forward with.
Yeah, we've yet to move to OpenAPI 3, but it's something that's on our radar to do soon.
Yeah, and I can strongly recommend it for a lot of these data processing aspects. We made the big splash around it about the whole OpenAPI 3, but there was a whole bunch of engineering changes and other key pieces of customer feedback and requirements that went into it, predominantly around data handling and how we make the data look like a real REST API or like a real COBOL application for everything that is going on there, rather than some of the kind of more hybrid attempts that we had in earlier versions of ZOS Connect.
Thank you.
No problems.
Thanks for the question, Ian. I'll just pause again. While we're waiting, Andrew, I think at one point you were doubting whether the PL1 support for API requester was available. So I took it upon myself to double check.
Thank you.
So PO1 support for API requests around Kix is available. It's been available since February.
Since February, thank you. Shipping every month, you lose track of what's gone out and what hasn't.
Just give another 10 seconds. If you've got a question, now's the time.
If anything does come up after the session and you suddenly have a burning question, my contact details are available via the GSE website, or my email is smithson@uk.ibm.com. I'm very happy to receive questions there, or you can look me up on LinkedIn or anything like that.
Okay, I think we're done. So thank you again, Andrew, for an excellent session. Thank you everybody who's attended this session and who attended any of our sessions today. That's the last session for GSE for today, so we can all go home or go through the next room. We're starting again tomorrow morning, 9 a.m. We have 2 Kix sessions tomorrow morning. One at 9 a.m. is on storage violations, and the second one is at 10:30. It's a customer experience presentation, generally the best sessions we get at GSE, and that is on experiences of upgrading to Kix TS 6.1. So hopefully we'll see you at one or both of those sessions tomorrow morning. Final thank you again to Andrew, and I will now close the session.
Thank you very much, everyone. Have a good evening.